Okay, so welcome back, everybody. My name is Guillermo Velarde. I'm from North Carolina State University. My first goal today is to keep you awake. It was a pretty big lunch for everybody here. And this is basically my contact information. You got my email right here. And I'm going to talk to you about biomass, pretreatments, and logistics. That's going to be the main focus of my talk. So basically, I'm from North Carolina State University, and we have this biomass energy and pellet characterization service center. Just wanted to let you guys know, the ones here and mostly the people watching the video later on, some of the capabilities that we have and some of the work that we can do for anybody out there. So basically, we can do any evaluation of biomass. We have different equipment and processes at our facility that we can use to help you guys out, improve all the different processes that are already in place, or develop the new ones that you want to incorporate in your facilities, or in case you want to open new facilities as well. So since we're here at the WERC, my focus was to be as educational as possible. So I'm going to have a lot of overview and give you some details of the different research and information that we have at NC State. So we're going to start with the basic concepts to basically understand the title of my talk today. So the first one is going to be the supply chain. The supply chain, in general, not just the wood products, involve all the different parties that are going to fulfill the customer needs, and that goes all the way from raw material all the way to a different product that people are needing or requiring at a certain point. And that's just an overview of how a supply chain works. So you have the suppliers on the left side, you have the customers on the right. You need the information flow going from left to right and right to left. The material should usually flow from left to right, always to the customer. And the most important thing is that money is going to flow from the customer to the supplier. That's the basic idea behind supply chain. In supply chain, we also talk about supply chain management, which means the coordination of all the efforts in that supply chain. And basically, I have a picture right here of the different elements involved in supply chain management. One of those elements, it's logistics. And logistics, it's part of the title of my talk. So that's why I had to go all the way to supply chain and logistics right here. Then the other concept, it's logistics itself. So that is itself a science of insurance, the movement from and to each segment of that supply chain. So it's basically focusing on the movement of either material, information, money, anything that's flowing throughout the supply chain, and being efficient doing it. So that's the key, being efficient in all that supply chain logistics. I'm also talking about biomass. Biomass, a lot of people have talked about that before. So it's biological material that it was either recently living or living itself. And when we talk about biomass for bioenergy, it's usually plant-based material. So that's the distinction. And in our case, we're going to, or in the work that I'm doing, I'm using both wood biomass and switchgrass. So a little bit of both. The other thing is pretreatment. We've been talking about pretreatment a lot today and yesterday, but it's basically a previous process that takes place to improve the conditions in the transformation unit. So I know there's a lot of confusion on what pretreatments are or what they're not. So there are different types of pretreatments, and that's where the confusion lies. So one is physical, we're changing physical properties of the materials. Another is chemical. We're including chemical additives like acids, alkali, and ionic liquids to change the composition of what we're dealing with. Biological, we're incorporating something else into it, or multiple, which means the combination of different one of those. And the most common is using physical and chemical together. I'm only going to be focusing on one of them, and it's going to be the physical ones. But then again, at the end, if you see an overview of the work that I'm doing, you know that you can actually use any of the different ones and get to similar results or the same methodology that I'm going to be using or explaining today. So what is biomass pretreatment and logistics? That's the title of my talk. So what we want to do, we want to ensure movements from each segment of the supply chain, of the biomass supply chain, are efficiently and economically as possible. And to do that, we're going to focus on pretreatment processes. And by that, I don't mean using something like this, which is overloading a truck to improve the supply chain. Hopefully that doesn't happen given the US for the regulations that we have in place, but in other places in the world, it happens. So that's a real picture. It's not a Photoshop or anything like that. So what's the relevance of our study? Basically, bioenergy, it's a developing industry without a mature market. That means we have to study the different elements and the different components of the entire industry, not just the transformation process itself. So we need to account also for the supply chain and figure out what's the best way to do it if possible. Also, transportation, it's huge in our industry. Throughout the seminar we talked about different radius of sourcing the materials, and that radius study basically implies that transportation, it's important. When we talk about life cycle assessment, transportation came up as a cost driver, not a big impact in the life cycle, but it's important in cost driver. So that's why we need to focus on the supply chain, because it's going to determine if we're profitable or not in our industry. The other thing is that we're talking about a commodity. Wood, it's a commodity, and we're competing against oil and other different energy elements which are commodities. And the important thing to understand about commodities is that we cannot drive the price of the industry. Basically, the industry as a whole are going to determine the price, so we need to adjust all of our operations to be able to meet those prices and get a profit out of it. So it's basically doing like a backward step. So we have the target price, and then we go back and reduce everything else to be as efficient as possible. And that's what we need to deal with. Also, it's not only what we do, it's also who we're competing against. They're also commodities, so we're like pretty much playing in the same field. But they're a mature market, and we're not. So that's why we need to improve to be as efficient as them, and actually to catch up to what other people have been doing in the past. So is this a new approach? Is the methodology that we were proposing here new? Has it been done before or not? So basically, I'm going to give you an example of something similar done in a different industry. And to do that, I'm going to tell you a little story. So there's this guy named Michael, and he was 19 years old. And he wanted to start a company that would dominate the industry. In his case, he had only $1,000 and a novel idea. Okay? So he was quite excited about the possibilities of his product and how it would change the society. As a customer, he was disappointed, because when he went to the store, people didn't know about that particular product. And his idea was to sell the products directly to people over the phone. Back then, there was no internet, so that wasn't an option back then. 3 years later, the guy went to get some extra money with a stock offering, and by that point, the company was already selling $150 million. And the guy was now 22 years old. So imagine somebody 22 years old with a company selling $150 million. The reality is that he found out that the necessity is mother of all the innovations, and that he learns by doing mistakes and making mistakes. And today, the company makes $57 billion in sales, and it's the leading market share in the United States. Have you heard this story before? So, what am I talking about? Michael Dell. So Dell computers, that means improving the supply chain has been done before. And I see a lot of people with computer here, and they have Dell computers. So the story is, it's true. it works around there. And the idea was to eliminate the retailer and sell directly to the customer. So let's improve the supply chain. That's what some people want to do. So going to an industry closer to us, we're talking about the wood industry. Do you think this has happened in the wood industry or not? Yes? No? I'm getting mixed signals here, so I'm going to keep going and see what people think. So any of you have helped somebody move to a different apartment, to a house? Yes? So for the people at home, everybody's going crazy here. They're raising their hands. They're saying, yes, we've helped people move. And they have to deal with stuff like this, right? A nice pickup truck or a van full of stuff, or even a moving truck full of furniture. This sounds familiar to all of you, right? So is there a problem with moving furniture like this? What? It's hard work, it's labor intensive. What else? Damage. Transportation costs. What about transportation costs? It costs gas. So you're transporting what there? A lot of furniture, a lot of empty room, a lot of furniture. So some people in the industry decided, well, that's not efficient. So let's do this. Let's put furniture and knock it down and have flat furniture that you can actually build later on, which means you're improving the transportation issues. You're going from transporting a lot of empty space in a truck to having everything as efficient as possible. So we've improved the supply chain in the wood industry. So it's doable. We've done it before. And that's the other example that I wanted to give you guys. So in terms of biomass, we have an entire big supply chain that we need to focus on, all the way going from the forest to the different industry, going to conversion facilities. So what we want to do, we want to focus on improving the supply chain of everything that goes between here and here. Okay? And it might be a challenge, and I will agree with you if you say that. So I'm going to try to do it as simple as possible. So that's the scope of our job, going from forest to a facility. So we're going to include all the transportation and all the different pretreatment activities that we can do in between. And we're going to exclude from our work all the harvesting. We're going to assume that we know how to grow trees and everybody does that very efficiently. And we're going to exclude all the conversion processes. There's a lot of different conversion processes, so we want to focus just on the logistics, as our name said. So it's just focusing on the middle part of the supply chain. That's our work. Okay? So the first thing that we're going to talk is transportation, very easily. So we want to be efficient in the use of our transportation. There are certain limitations when we talk about transportation. So the most common ones are going to be size of the transportation equipment and weight limitation. So even if you have a rail car or you have a truck car, we're going to have some constraints there. There's so much stuff that you can put into a transportation unit, either if it's weight or volume, or both. That would be ideal. Okay? Other thing about transportation, we're going to focus on the value-added material that we're transporting. Okay? So when we're talking about wood, wood has a lot of moisture and water into it. And in many cases, water is not the product that we want at the conversion facilities. That means that we're transporting something that we don't want to use at the end. It means we're wasting our resources. Okay, so water, it's present in wood, and it accounts for a lot of wood. When it's green wood, it's 55% moisture content, or something like that. You're moving a lot of wood. So we want to focus only on transporting the value-added part of our product. Okay, and it's going to be different depending on what the final product you want to make it's going to be, and I'll tell you a little bit about that later. Also, you want to understand volume. Volume, it's key in transportation. Here we have a picture that is showing you the same weight for different types of materials being moved. So one is round wood all the way to slash. Okay? There's constraints in the transportation, so obviously you're going to be efficient moving round wood in terms of volume over here, but not if you do slash, because the truck won't be able to manage that amount of volume, but the same weight, remember. And it's not only volume, it's also the type of material. We can have roundwood, bark, branches, or sawdust, or pine needles, or pretty much any different type of materials that we consider biomass in our industry, and they're going to deliver different heating values. So if we talk about heating values, we want to deliver that product that is going to provide us a higher heating value. In our case, that's the one that I'm focusing on. So the different materials are going to have different volumes, different weights, but also different heating values. So that's something that we need to consider in the study. Then it's also particle size. It could be shavings or sawdust, roundwood, or bark itself. And that particle size is going to affect something that we call the bulk density. That bulk density is the one that's going to determine us if we're going to reach our maximum requirements through volume or through weight in transportation. So it's not only the heating value of the material, it's the bulk density. So the combination of the both of them, it's going to determine how well or how not so efficient we're doing the transportation. Then we're also considering some that we call modifications to the product itself. So one of them is pellets. So if you heard the presentation before, you know everything you need to know about pellets. And the other one is sorefaction. It's also been discussed here before. So it's changing the properties to improve, one, the bulk density of the material and the heating value in terms of as a ratio to the weight of the product. So basically those are the two different things that we can do to improve our supply chain as well. So we want to focus on recognizing the value of the material. Just figure out what's the value of the material for the determining transformation process that you want to have, and try to just transport that value-added material. We want to increase the bulk density to reduce the transportation cost, and we want to increase the energy content output per unit of weight. So those are the two main keys in transportation. And by doing that, you can actually expand the supply region and at different competitive levels. So let's say that a company X was being able to go 40 miles away to get the raw materials. If you improve your transportation, you might be able to go 50 or 60 miles radius at the same target price or same cost for your facility. And at the end, what you want to do is gain a competitive advantage in the industry. So there's a lot of people doing the same activities. We're competing with all the different industries in the forest industry or the wood products industry. So having that extra advantage is going to help you stay positive in your cash flow and results at the end. So the big picture is that there's not a single approach, okay? And that's the case for the industry. We have different feedstock, we have different processes and different products. So when we talk about focusing on the right type of value-added product, it means going all the way to the end, see what do you want to make, and try to track back all the way to what's your product that you're going to be using, and follow that material that's actually going to create an impact in your final product. And just focus on that one and try to eliminate everything else that it's going to make your job later on much harder. So the overview of what we do is basically we have a forest somewhere and a nice conversion facility. So what we do, we move the material from the forest to the conversion facility. But what happens if that conversion facility, instead of being this big, becomes this big? So what we need other sources of material. So we need to find a different forest and source material from there. And if we keep going and we want to produce more, we need a different forest that might be a little bit further away, and we need to source from them, right? But in that case, it might not be feasible at that point. So what we need to do in our case is concentrate all that biomass, focus on that value-added product that it's important for our industry, and go to a pre-processing activity. Okay? And that's what we have here. We're taking the biomass as a whole, doing a pre-process activity in the middle, just taking that value-added product, and that value-added product will move it to our facility. So the big question is it feasible? And I can tell you with 100% certain that the answer is maybe. It depends. It depends on many different variables in your unique situation. Everybody's going to have a unique situation, and it can work or it can well not work. It depends on what you do and where your sources of materials are. So the first thing that you need to account for is the cost of raw materials. It's been changing throughout the years, and there's different types of raw materials for each industry. So that's the first target that you need to account for. Also, what are the characteristics of the materials? Are you being able to purchase sawdust or lumber or different type of things as well? Also, the amount of the material. When we talk about logistics, we talk about the long-term improvement of the supply chain. We're not talking about, well, somebody's going to develop a neighborhood and they're going to cut some forest to have a neighborhood, so we're going to have a one-time pool of material. No, what we want to know is how much material can we have throughout the years, and that's something that we need to focus on, not a one-time thing. Also, the distance to our facility. Where is that pool of raw materials compared to us? And how much is that going to impact our overall processes? Basically, the cost of transporting that material to our facilities and looking at all the different options, not just one. Like I said here, we got, in one case, rail or trucks. Just look at everything, or the different options that you have, depending on the source of your material and where you're located. And the third one, it's the impact of pretreatments. Impact in terms of money, in terms of life cycle assessment, and all the different aspects that mostly going to add some logistics issues and supply chain issues to your facility. So we got 3 different areas that we need to account for that it's going to determine if the process is going to be feasible or not in each particular case. And basically this is what we can do for anybody out there. If you guys can come to us and say, well, this is my situation, can we do this or not? Then we can run some models, tell you exactly if it's going to work or not, or what exactly are the conditions, when and if it will work. So the conclusions of my talk is that there is an opportunity to improve the supply chain. Okay, and the focus of any wood industry right now geared toward bioenergy is that the continuous improvement is the right key. We should always try to improve and keep improving the whole time. Also, the path to follow, it's unique in each situation. Depending on the different characteristics of each industry, it's going to be different. Okay, so that's what we need to incorporate in our analysis to tell you if it's going to work or not. There's not a single answer to everyone. The analysis should be centered on value. Okay, we're going to look at what the value of the raw material is towards your end product, and we're focusing on that. And then it's not always about money, but in most cases it is. Sadly, it's true. Even the people doing the LCA might agree with us, but that's a big key component in our decision making. But all the variables need to be accounted for, and the one that I like to focus on a lot is energy. Does it make sense from an energy perspective to do all of this transportation and logistics and pretreatments to actually get to that final product? So it's not only money, it's also energy, and I would also like to add the LCA part as well. And the final one is that we shouldn't forget about the incentive. So if we're talking about logistics, we're talking about long-term. Incentive might not be there long-term. So if something makes sense today, might not make sense tomorrow or 2020 or along the road. So that's the other thing that we need to account for and take in consideration when we decide on what we want to do for our industry. So I just want to acknowledge the people that help us. This work has been funded by the Sun Grant Initiative, and we've been working in close relationship with the University of Tennessee, Knoxville, in our work. And with that, I want to open the floor for any questions that anyone might have.